Click on the job. These are the logs showing us what happened during the job execution in this terminal window. You can see that the job logs are divided into many sections. Each of the section depicts a different background process GitLab performed while running this job. You might be wondering that in my YML file, I did not define any Python version or the environment to run this Python code, any Docker image or so. Nothing was defined, still the code ran automatically, right? All of your doubts will be cleared from this execution log. Starting from when the job was started. In terminal it says running with GitLab runner 13.12, which is some Docker based runner. Actually guys, in GitLab, the scripts defined in your jobs are not run by the GitLab server itself. Rather, they are run by a dedicated application called GitLab Runner. And here also it is showing us the stats of the runner that was used to run this job. Since in our YML code we had not specified any particular runner it should use, so by default GitLab has auto-selected some shared runner. This is how the codes are run on GitLab. In case you do not specify any runner explicitly in your pipeline, GitLab automatically selects some shared runner to perform those jobs. A runner in short is basically a lightweight and highly scalable agent that works with GitLab CI/CD to pick up a CI job, runs the job and send those results back to GitLab instance. I won't go deep into runner at this stage as it is explained in detail somewhere next in the course. For the time being, just keep in mind that GitLab itself do not perform any jobs. Rather, it has some dedicated agent, the GitLab runner, which by default runs the jobs over some external machines, and after performing the jobs, it sends back the results to GitLab server. Anyways, the next step, it is preparing the Docker machine executor. Obviously, a code would need an environment to run. That is why, even though you don't define it in YAML file, GitLab will automatically spin up an environment for your code, which is nothing but a Docker image. And here it is, Docker with Ruby version 2.5 image on it. Then it's preparing some environment. Next, after the environment is created, at this level, it's getting the source code from our repository. And finally, at this step, the runner started running the job script, which is to execute a Python script hello.py. After running, the output of the Python code is returned, which was a print statement of hello words. After the execution is completed, cleanup activities are performed. Like whatever was assigned to this job, the shared or any other resources are taken back, temporary data of this job will be deleted, and finally the job is succeeded. So these were the steps that are performed automatically to get your job done. And on the right side of these log statements, you get the time spent in each step. And here in the right pane, we have a retry button if you wish to manually rerun this job. Note that rerun this job only and not the whole pipeline. This retry button is to rerun this particular job only. Then we have the total duration in seconds this job took to execute. Again, keep in mind that these logs and details are for the one job in the pipeline and not for the whole pipeline. So these 34 seconds is the time took for this job to complete and not for the whole pipeline. Then we have timeout, which is set to default 1 hour value. Timeout for a job defines maximum job timeout for each runner. This feature can be used to prevent your shared runner from being overwhelmed by a project that has jobs with a long timeout, for example weeks. This being explained, let's retry this job and see the live execution of these logs. Our job is started again and is performing the steps one by one. It is preparing the Docker machine executor. Pulling the Docker image of Ruby 2.5. It has complete, now preparing environment. And next all the steps are done within a moment. And finally the job succeeded. And guys, if you want to check the status of any of your jobs, you can check them from this jobs page at here. As we have run our job 2 times, so we got 2 jobs here. Great. Good so far. Now that we have defined a pipeline for our Hello World Python application, from now on, whenever you make any change in the Python code, by change I mean you do a commit in the repository, your pipeline will get triggered automatically, means the Hello World application will run. Let me just demonstrate it for you. For saving us some time, I will simply add those changes directly from GitLab UI. Let us change the print statement. Commit it. Commit message is fine. Changes are committed. Now open CI/CD pipeline. Excellent. As you can see, as soon as there was a commit into dev1 branch, the YML file was automatically triggered and it has automatically started running the pipeline for us. Just try to correlate this small example with any real-time project. If you would have defined a proper pipeline with steps to build, test and deploy the code for a full-fledged large-scale application, in that case also, anytime a developer will commit his change, the full pipeline would automatically perform those steps. And if at all the things go as per plan, that change will probably go live within few minutes of commit. That's the power of CI/CD. This run is also succeeded. Now what's next? Follow the CI/CD principles. As per the CI/CD principles, once you have tested the code into your own branch and have confidence on it, you go ahead and merge this branch into master branch so as to keep it updated. Let's do it quickly. Repeat the same merging steps. You have two options. New merge request. Source branch is dev1. Target is master. This is the latest commit. Approve is optional. I will directly merge it. It is merged. Go to CI/CD. Now guys, the same logic applies to master branch as well. That is, whenever a change is encountered in the master branch, the pipeline is automatically triggered. See, you can even see it here. This run is for master branch. But it's up to you if you want to let it run automatically or not. Why? Because master branch is usually associated with production environment, so you would definitely not allow all the developers to merge their branches into production for every single commit and let them play with it. There would be a lot many developers working on a project, so running the production pipeline for each of their commit is not a good idea. So you usually set some criteria on when to run the master branch. That is why you usually exclude the master branch from automatic pipeline trigger upon code commit. In fact, for every other branch you can set this property, that whether or not to run the pipeline automatically upon receiving a change in the code. How to do this is our later point of discussion, but since as of now I have not made those settings, so the pipeline got automatically triggered and ran for master branch too. It is completed. Okay, so here comes the end of this lecture. Before we move to the next class, again I would like to tell you that this was a very basics of basic example. My motto of this lecture was just to introduce you with the GitLab CI file and show you how GitLab CI works. I know from our pipeline there were so many things missing, like we have not written any test cases, the build methods and other things. But no worries, as we go along in this course, we will add more and more options in our pipeline. Your takeaway from this example should be that whenever there is a code commit into the repository, that commit will automatically trigger your defined CI/CD pipeline. See you next lecture.